Hello and welcome to the ASC video series. We're looking at Introduction to Statistics, STA 2023. This is going to be a problem from Chapter 4 concerning binomial distributions. So here I've copied a problem from the homework. It says American Airlines flights from Fort Lauderdale to Atlanta are on time 90% of the time. Suppose 12 flights are randomly selected and the number of on-time flights is recorded. Determine the following probabilities. Round solutions to 4 decimal places if necessary. Okay, so the first thing we need to do is recognize that the setup here represents a binomial experiment. What makes that a binomial experiment? So there are 3 properties that you need to check. Number 1 is that there is a fixed number of trials or outcomes that we're going to look at. 12, that's the number. The second thing is that these are independent outcomes. They don't really have anything to do with each other. They don't affect each other. And you might say to me, well, Sean, might these not affect each other? I mean, you're having 12 flights. Sometimes flights are, late because the other ones are late or for the same reasons. What if there's bad weather? Shouldn't we expect them to maybe not be independent? And the answer is, well, they've told us that they are randomly selected flights. So that's going to decouple these from circumstances that might make them not independent. So anytime you see randomly selected, you can pretty much guarantee these are going to be independent. Finally, we only have 2 outcomes. That's the in binomial. And these outcomes have fixed probabilities, P and Q, which is just 1 minus P. So for our problem, we recognize that when they're talking about the probability of being on time, we are given that P is equal to 0.9. And that means that Q is going to be equal to 0.1. Now that we know we're dealing with a binomial distribution, we can calculate the probabilities using the binomial probability formula. So just to be clear, probability of x being equal to some value is going to be given by n, the number of outcomes, number of trials, choose x. So this is a combinatorial formula. We'll look at this in more detail, times the probability raised to the xth power times the q probability raised to the n minus xth power. So NCX is defined in terms of factorials. This will be n factorial divided by the product x factorial times n minus x factorial. Recall that a factorial is just, for a positive integer, the descending product. So we take n times n minus 1, and so on, all the way down to 3 and 2. You don't really need the 1, but I included it for aesthetic reasons. So what can we do with that formula? Well, we're going to be able to calculate the first probability at the very least. This is for x equal to 7. So here we have the substitution. I'm just replacing n with 12 and x with 7. And then we're going to do this product in the calculator. Speaking of calculators, let's look at how to do this in the calculator, specifically the 12 choose 7 part. So I'm going to first type in the 12, then I'm going to go to math, over to probability, and down to NCR. Enter, and this will give me 12 choose 7. So let's put that in parentheses, and then we're going to times that by 0.9 to the 7 times 0.1 to the 5, which is 12 minus 7, and so on. And rounded appropriately, that's 0.0038. Before we move on, we should note that there is also a function on the calculator that will do binomial calculations. So second dister, and then let's go up to binom PDF. And when we click on that, we are prompted for the number of trials, which is 12, P, which is 0.9, the probability of being on time, and the x value we were interested in, which in this case was 7. And notice that that just sets up the function in this format, right? So this is, that is to say, this is also equal to binom PDF of n the number of trials, P, the probability of success, and X, the thing that we are interested in. Now, when we type enter on the calculator, it will give us the same number. So now we are looking at the probability that there are at most 9 flights, and this is the same as being X less than or equal to 9. So 0, 1, 2, up to 9 is fine. And then we are going to add up all of those. So there's already one function on the calculator, which is binom CDF, which will add up all of these. So this is the same as the probability of X less than or equal to 9 in this case. The P here stands for probability. This is binomial probability distribution function. And the C here is the cumulative distribution function. It adds up all of the values less than or equal to 9. So let's bring back our calculator. So to find that, we go back to distributions and we go up to binom CDF. 12 trials, probability of 0.9, and an X value of 9. Now in binom CDF, we'll add up all the values less than or equal to 9. So we have 0.11086 and so on. Rounded appropriately, that's going to be 0.1109. There we go. Now for this last one, we're talking about at least 5 flights, and this is greater than or equal to 5. And what we can use here is the complement rule of probability to rewrite this using a cumulative distribution function. So notice that we can simply rewrite this using the idea that it is 1 minus the probability of not this happening. So what happens when I negate this? I wind up with the probability X is less than 5, strictly less than 5. Now that is the same as the probability that it is less than or equal to 4. That's because there's no 4.5 trials in this condition. You can't have 4.5 planes be on time. These are whole numbers only, and so these two, X is less than 5 or X is less than or equal to 4, are equivalent conditions. Now that it's in the form of the cumulative binomial distribution, less than or equal to 4, all the values up to 4, now we just take that away from 1. So back to our calculator, we take 1 minus second distor up to binom CDF, and we already have these in there from the last one. We're going to put this now at 4 and paste. And we get a lot of 9s, 0.99, 999, and so on. Okay. So that's all there is to that. I hope this was helpful, and good luck with your studies.